everyone. We are back with a new episode of APIM Hotrod. Today we are here with the great Richard Hupa and also, as usual, my great friend Stephane. How are you doing, guys?
Richard.
Yeah, I'm good, thank you. Thanks for having me.
Happy to be here as well, Massimo, as usual. So what are we going to talk about today?
Today we're going to talk about AKS, Azure Kubernetes Service, and I'm extremely excited because Richard is one of the people that really helped me in my, approach to AKS. He really, in the past years, helped me to learn AKS, and I always follow his articles and all the initiatives that Richard put, all the efforts that he puts in the community. So it's a great episode for me.
Thanks for being with us, Richard, because indeed he's a great voice in the AKS world. So
as every time we have our wonderful map designed by Stephane that can help us navigate into the AKS world. So this is dedicated to AKS, so divided by monitoring, scaling and networking, high availability, and so on. But okay, it's a huge kind of things. AKS is a service that really evolved a lot during the latest years. So I would like to start with to ask to Richard, in his opinion, where we are with AKS, where AKS is heading to.
Yeah, good question. So I've been with AKS before it was even AKS. So the journey, seeing it from ACS, Azure Container Services, all the way up to AKS has been amazing. That journey, it's not just been the last year. The last year has been crazy with the stuff they've been pushing out. Maybe that's all thanks to the AI. Maybe they're using AI in the background to help push the development on. I don't know, but that journey has been awesome. And I think we're at a point now with AKS where it is, with the thanks to AKS Automatic, which just went GA recently, we're at a point where it is one of the most stable products in Azure, in my opinion. It's using some core services that have been around for a long time: virtual machines, virtual machine scale sets, and load balancers. It's using these core services, and it's now just at that point where I don't think there's much more they can do, but they do surprise me all the time with new features. Like they've just brought in the Carpenter stuff, which is basically a new way of doing your node pools. So instead of a virtual machine scale sets, it uses virtual machines, but this Carpenter operator then queries the Azure Resource Manager APIs and picks the best VM size for your workloads to try and keep everything small. And then on top of that, they've also just brought out virtual machine SKU nodes, so you can actually just add a virtual machine to your AKS cluster instead of this whole virtual machine node pool. You can add like up to 5 different VMs inside your node pool, and it's crazy. They always shock me. But what I would love to see, and this is one of my biggest pain points, is every time you have an AKS cluster, you have to have your system node pool, which is compute running things like core DNS, your core services, and you have to have at least 2, maybe 3 in production, depending on the size of your cluster, always running, sat there working for it. Whereas to me, I don't want to see that stuff. I just want that gone away. So I would like AKS to just have the AKS control plane, which is paid for. You can have a free version, but I'd have a paid for version. And then just my workload. And that's all I want. I don't care about the system pods that Microsoft manage them. Most of them are part of Microsoft anyway. That's where I would love to see it go. If it does or not is a different story, but I really want to see that.
But still, I would like to still see visibility, of course, right, on how the system is behaving.
When I do kubectl get pods, I want to see them. Yeah,
because sometimes that's one of my frustrations with container apps. Yeah? So that is that actually it's abstracted away, which is good, but sometimes a bit when you really want to dive a bit deeper, then you don't have access to it. But okay, but I see. So you want somehow to, but I think it's really indeed heading there that it makes it easier and easier to use AKS, right, compared to what it used to be years ago. Which is good. I think that's indeed one of the, it's funny because you mentioned Carpenter and the Massimo, I see that you were showing the map and it's not in there. So that's funny because that's one thing that I did not put, which is indeed quite recent.
It is here, Stephane. It is here. Look,
I put it.
NAP.
No. No, sorry, I put it.
Yes, no auto provision. Yeah.
Good. I was not sure anymore. Okay, no, I was looking for Carpenter. No, that's very great.
Yeah.
You know my map even better than mine.
Use the Carpenter. I said Carpenter, but myself call it NAP. So you know, like sometimes we get lost in this naming and rebranding and all these kind of things.
We can show the link between the two, but indeed, so that's kind of good addition to. The one thing, what the map shows is that it's like a huge service, right? AKS, I always say it's kind of a universe within the universe, right? It's really a plus, of course, if you link this to the CNCF landscape, it's much bigger. Then, of course, then it becomes really a lifetime job if you really want to be, let's say, expert in this. But Richard, maybe one topic that I see a lot, let's say a lot of debates around still today, although it sometimes could be surprising because, Kubernetes even before AKS is not new, it's been there for years and years and years. It's like logical isolation in terms of security and so on. So I see in some companies, some industries, some it's a no-brainer, they share clusters, right? And you have like multiple apps, even sometimes completely different profiles, real shared clusters, right? And then you have governance around it. And then, or some use dedicated clusters, right? Like one customer at some point had 450 dedicated clusters, right? So quite a lot of clusters. And they said, for us, it's actually easier because then we don't need to be too, strong in terms of inside the cluster governance because it's all dedicated anyway. What's your feedback on this? I mean, what do you see on the field with your own customers?
Yeah, that's a good question. So I used to be in the realms of shared clusters, but then you can get the issues of noisy neighbors and stuff like that, with the infrastructure side, especially if a developer puts a rogue app on, doesn't put requests and limits in correctly, So I used to be down that route until I actually had to start troubleshooting these kind of issues, and the whole system was down rather than just like the whole customer base was down rather than just one customer. So then Microsoft created Fleet Manager, which is a tool for managing multiple Kubernetes clusters, and it's based on an open source project called Fleet Manager, I think it is. And this basically lets me manage multiple clusters through one API. So your customer, you had 450. I've got customers with hundreds of clusters too, and we can just configure Fleet Manager to manage all of the updates for us automatically. We can do like gates in between the different ones, so dev, prod, and that. We can say, right, we'll do all of these ones first, wait for a bit, and then we'll do these, or we'll do this ring of customers at a time, then this ring of customers after we're happy they're done, even do it through regions. And with Fleet Manager now as well, if we need to do deployments of our software and they all need to be updated at exactly the same time, we can just tell Fleet to go and update. We just like hit the Fleet API and then it will synchronize it out to all of my clusters for me. So that to me outweighs the issue of having to troubleshoot and controlling that blast radius of like one rogue pod could bring all of my customers down, whereas now they're separated. So I prefer that. And if the AKS team ever gets rid of that system node pool, it will be a better option because you don't have that extra compute paying, which you have to pay for. So that's the way I go. But some customers still want that shared cluster because it's easier for them to manage. And
I think it's also so go ahead,
Massimo. Or maybe I will. No, go ahead, Massimo.
No, but that I'm also for the fit the purpose cluster kind of things. But as a lot of time it depends the size of the organization, right? So if you are a bigger size, you can handle that huge amount of clusters. And the question that it came to my mind while you were talking, guys, is just like also how much freedom do you give to your owners of those small clusters, because in my experience, I saw when you have this huge amount of fleet, you have a lot of strict, let's say, rule of the game pushed by platform engineering. So use, for example, that Archivault and not using that service. So you can then do whatever application you want within that cluster, but the rules of the game to keep those fleet manageable are quite standardized, quite high. Do you see the same?
Yeah, but I think I will, because then I will also bounce on what I wanted to say. So I think that actually working with dedicated clusters is easier. You can delegate more because somehow, again, the blast radius will be, okay, that's going to be the cluster of a given application team or given solution team. So somehow, okay, you can delegate more, even in Kubernetes RBAC. You see the combination Azure and Kubernetes RBAC, then you can say, okay, you can do more in your cluster because it's your cluster. You could see that like with resource group, if I would have to make an analogy, right? Why, if it's really shared, it's actually harder. For me, the benefit of shared cluster is like application density. You might say, okay, that you somehow, the compute you spend, normally if you have the right density, then you don't waste compute, right? That's maybe one of the benefits. But indeed, the downside is that if you really have very different apps in the same, with different profiles in the same cluster, then your inside cluster governance needs to be much more robust. You mentioned noisy neighbor. All of that can be controlled, but that requires more efforts, like putting policies, resource limits. You mentioned that. Yeah, you can enforce this with policies and so on. Worst case, you could say even a shared cluster, some potential noisy neighbors, you isolate them to a node pool, for instance, right? And then we dedicate it. But then you need to work with node affinities, to make sure that they are not polluting the other node pools. You can work with pod priority. So there are ways in Kubernetes to respond to all these potential issues. But if you don't do anything, that's true. That's out of the box. If you don't do anything, if one pod without resource limits is actually eating the whole resource of a node, especially memory, then we start eating pods everywhere. And indeed, so the blast radius could be huge. And I really had a story like this, but that was a dedicated cluster anyway, but just to show how it could. Back in the days, I worked open service mesh. I used that. They deprecated Microsoft in the meantime. But at some point, we injected all the pods at the same time with OSM. And so we had no pod priorities and so on. And actually, it killed the whole cluster. It was a dedicated one, so that was okay. But there was one setting in OSM, capturing metrics, computing statistics, that was really eating a lot. And so the bigger the mesh was, the more compute and the more memory it was consuming. And so it was kind of exponential, you see? And so we initially just tried with one namespace, and then we had just saying 10, 15 pods in that one. But actually then we said, okay, let's enable it for the whole cluster. And we had about 40 namespaces, and then it really exploded everything. So if you have this in a shared cluster, right, with other apps, then you can imagine that. So that's the let's say downside of shared clusters. It requires really much more governance to be more strict on this.
Yeah, governance is definitely key. It's you can get started without governance, but you find you really need it very quickly.
Indeed. And so let's imagine even within for dedicated clusters. So today, how are your customers dealing with logical isolation? Because you might even say, that you have microservices or even NT or whatever kind of architecture style, but you want maybe not to have everything all opened, right, in your cluster. So today, what you see mostly used? Is that Calico? Is that like Cilium network policies?
Good question. Mostly, we see actual standard Kubernetes network policies over Calico and Cilium because, Cilium's only been pushed in the last year or so. Yes, I think that is the direction Microsoft are pushing more their development, but it looks like thanks to eBPF and stuff. Yeah. So if anyone is running Calico or that, I would look at ways to migrate to Cilium. That's something I'm doing for quite a few of my customers already, that we did put on Calico because Calico was the only option for global network policies until Cilium came out. So but I do see mostly, if it's not a global policy needed, it will just be a standard Kubernetes network policy. I don't really see many customers going down the Cilium network policy route. we're starting to see more with the new feature, the Azure Container, the Advanced Container Networking Service. I think it's ACNS, which gives you extra abilities with the Cilium policies. So you got your layer 7 policies, so you can do DNS blocks rather than just IP. And I think that's where most people will prefer. But obviously, bigger enterprises will be using Azure Firewall or an MVA anyway, which can do that. So, it's one of those ones.
Yeah, and that actually, because also something I could see recently is the egress static gateway. I don't know if that rings a bell, which is something that Microsoft added for internet-bound traffic. To be honest, I'm a bit surprised with this one because, as you said, I don't know any organization today that is letting AKS directly talk to internet, right? Typically go through an NDA. So internet-bound traffic is anyway captured and managed there, and then you can observe it and so on. But in your opinion, would it make sense to have let's say that you have more in a shared cluster situation, that you would be able to identify which, let's say, application from inside the cluster is talking to a PaaS service. You could even use energy rules to say, okay, that PaaS service is locked down to you. Today, we don't have this. So with the egress static gateway, that's something you could have, but for internet-bound traffic, but again, it's anyway brought it to NVAs today. I don't know really what needs they try to fulfill there. But if you were to have the same capability for internal traffic, I think it would make sense. But what do you think about this one?
Yeah, so the static egress gateway, I think the need is there's going to be some customers where they may not want to route part of their traffic out through the firewall because a customer of theirs might be able to connect to any webhook or any SOAP service back in the day, any service that they need to, and we won't be able to add that to the firewall rules quick enough. So instead of routing it out through the firewall, which will get blocked, they say, right, route out by a static egress gateway, which will bypass our firewall, but only for this pod or this pods with these labels. And then that way, a customer could say, right, my app which is running inside your cluster, can talk to my webhook in my Azure or in my AWS or wherever it's going to run. And that's really the only reason I can see for these in Azure.
But let's say industries like financial and so on, that will never fly, you see. So they really want to see that's actually, it makes them happy to see firewall blocking stuff, because that's the role of firewalls. They really want to control completely. But for internal traffic, I think would make sense too. So call to Microsoft if you can do something about it. That will really help, especially in shared clusters, because if you go outside the cluster, you just know the cluster is talking to you. And even if you use Azure CNI, pods are routable IPs and so on, but still pods are volatile, right? So you cannot rely on the pod IP, even if it's not outside the cluster, to say, I would put energy rules or whatever. But just to see a bit. But you also see that most customers route stuff to firewalls for internet.
See, this is where the Azure, the Advanced Container Network Service with the layer 7 would come in handy for the internal traffic to go out, but only pods with the label that match the network policy, the layer 7 network policy, can reach the DNS name, even if it's DNS name of my internal app. So
And now, because you mentioned a couple of times these advanced container network services, so I have to say very slowly, because otherwise it will be a problem for me. It also came to my mind what I was struggling a couple of months ago, out of the blue, traffic or part of the traffic is not working anymore. What's going wrong? It's always on Kubernetes, or it's DNS, or it's network policies. The usual suspects.
Or service mesh.
Yes, or service mesh.
Or service mesh. So at the end of the day, I ended up to just try to debug network policy, understand which kind of network policy was blocking which kind of traffic. So what are the options? In my case, was very easy. I just use a hub UI I filtered my truck by dropped, and man, it was like, oh, I'm living in a new world. But yeah, if we don't have these advanced container network services, there are other kind of techniques. So how does it work?
Yeah. So there's a tool which is actually part of the Azure, the Advanced Container Network Service called Inspector Gadget. It's an open source tool built by the people that built Flatcar, which is an operating system for Linux and Kubernetes specific. They built some other tools like what's the dashboard UI one? I can't remember the name of it now. I use it a lot as well. Headlamp. I should have remembered that because I love the tool. I use it a lot for my UI for Kubernetes. And they built this tool, Inspector Gadget, which is basically part of the Azure Container Network, the Advanced Network Service, but it runs these gadgets, which are like eBPF applications inside your cluster to help you figure out what's going wrong with your network. So you can do tracing of your DNS, see if there's any DNS failures, tracing the network traffic, seeing if there's any dropped packets and stuff like that. So the Advanced Container Network makes it a lot easier because it services it in Hubble or inside a Grafana dashboard for you, but you can just do it all through the command line using Inspector Gadget. So that's the first place I would always look for if I'm doing any network troubleshooting inside the cluster. You have, I think it's KubeShark as well, which is a cool little tool, which is open source. You can run that, and it's like Wireshark but for Kubernetes. And yeah, the logo is quite nice because it's a shark and stuff. But Inspector Gadget's my go-to tool for sure.
Okay, I have a little stupid joke now. Sorry, because you mentioned a headlamp. I thought you developed the headlamp because it's fully branded with your
yeah, I know.
black and yellow.
Yeah, I wish I did develop it, but it's a really good tool. So if anyone is looking at a UI for Kubernetes, use Headlamp because it's also been incorporated into the SIG UI for Kubernetes now as well. So it's like it is part of the CNCF and is the one people want to use. And yeah, it works.
I also love it. My love goes 50% with headlamp and 50% with K9S. So those are the two things that I really love when I interact with Kubernetes clusters. Yeah. Cool stuff. But I have another question. So I would like to just go a little back on when you mentioned to AKS Automatic. So the question here is a little bit philosophical, maybe. So AKS Automatic is, from one side, is an SKU. On the other side, it is a Kubernetes cluster already configured with a lot of best practices. So wonderful. So so there are, this sentence looks really two different words, completely different. Is it a SKU? Or is it something that I can roll it out in an infrastructure as code in a controlled way? So if then I change the SKU, what happened? I just roll back all the things. So just help me with my confusion here.
Yeah. So the official term is it's an opinionated AKS deployment, as in Microsoft has put what they believe to be the best practices in from what they see from all of their customers. And it's a good way to start your journey with Kubernetes because a lot of the best practices are enabled by default, but you can then change it from an automatic cluster to a standard AKS cluster, which is what we are familiar with and we've been using for many years. I don't know if you can actually switch from a standard to an automatic, though, because then it would enable a load of things and probably break everything. But yeah, it is technically a SKU. But it's just, it just enables node auto provision, so the Carpenter out of the box for you. Deployment safeguards, so it ensures that you're not putting applications in your cluster that may not have the best practices on it. But with AKS Automatic, it's not just the cluster. They have this other part of it where you can point it to your Git repository where your code lives for your application, and then it will go off and create you a Docker file, Helm chart, or just Kubernetes manifest files and stuff like that. And then also create your GitHub action to deploy it to your cluster. So it's
So
it's
not
a
only
different mindset.
infrastructure, but also the tools for developers. So it's a double audience, right?
Yeah, exactly. But all these tools that AKS Automatic has, you can use yourself. So the tooling they use to create and package your application is use Draft V2, which is just an open source tool. You can use that. It's built into the Visual Studio Code, Kubernetes extension, the AKS extension is built into that. So you can just right click and do it yourself there. And AKS Automatic is just an opinionated version. So you could just deploy, if you knew what you're doing with Kubernetes and all of the Bicep Terraform, you could just pick all the services that Microsoft have documented they've put on their stuff and then just deploy it out yourself, and then you've got best of both worlds.
Yeah, probably indeed. I guess that the first audience is indeed newcomers, I would say, to AKS and so on. Because if you really already deploy AKS clusters for years, right, you already have all the automation in place and succeed. So that's maybe typically you would also use, well, of course, you have the cluster itself, add-ons and so on, and then you will typically use. It escapes me now. The GitHub solution, Argo CD, for instance,
Argo CD, Flux,
and so on. But indeed, it can be overwhelming as well. So I think the goal is to actually package something that is already more enterprise ready from day one. Yeah, that's I guess the ambition there.
And for me, I'm going to probably say something that a lot of people don't agree with, but for me, I think AKS Automatic is sort of a better solution than ACA because you have the power of Kubernetes. You don't need to manage the Kubernetes part because it's all managed with the AKS Automatic, all the auto updates, but it gives you that better troubleshooting experience. Yeah. Thanks to the new AKS agent, which has just been released as well with the AKS MCP server. So you can now just ask your CLI AZ AKS, why is my pod in the crash loop back off? And it will go and tell you everything. Whereas you try and do anything like that inside ACA, you can't even run a debug container inside ACA. So I think AKS Automatic is coming for ACA.
That makes me smile because I'm sure this conversation, ACA versus automatic, it will be. I mean, in the coming months, it will be in every table, in every room of technical people. It will create a huge amount of different opinion and a huge discussion.
You already had a discussion ACS versus AKS, and that's something that is already there for quite some time. And indeed, the downside, what was considered the downside of AKS is that, okay, you can do everything, but it's, of course, more work, more complicated than ACA. But indeed, somehow it's a way to make it less complicated, but still with the power of still viewing what's going on and so on. So I think AKS as a whole remains, because there is also something we discussed last time, Richard, but that was more on the infra topic. But anyway, solution architecture. Yeah, AKS still also an advantage I see compared to ACA is, of course, that if you need to host vendor packages, they are typically either designed for OpenShift or Kubernetes. See what I mean? So because they want to be neutral and so on. And so that's still for ACA, for me, it's okay for custom apps that you build yourself. Then, of course, if you already have indeed, you plan to use Dapper Key, then so it's all built in, all managed, easy, picky, good. But if you have to take vendor packages, okay, how do you deal with that? Right? And that's where, for me, AKS remains something that's very interesting from that perspective.
Yeah, I guess the biggest advantage of ACA is the cost aspect because it's is it per second billing or something like that? But it's very low. They have their idle pricing and stuff. If we go back to my beginning thing, what I would like to see in AKS happen, and that system nodal goes away, and with the likes of Carpenter, the node auto provisioning, being able to provision these VMs when they need to reconcile them back to different sizes and stuff. If Azure ever changed the pricing model for the VMs instead of per hour to be per second per minute, then I think AKS could be very cheap in the long run, and that's where I would really love to see.
Okay, let's put it together. So this NAP that is scaling at the speed of light, billing per second, And then all of these modern tools, like you mentioned MCP for AKS, the SRE agent that recently went public, publicly available, that helps also with troubleshooting and also give you a summarization of what's going on your cluster. So all of these things will make, in some way, will democratize this kind of beast that is Kubernetes for developers and people in general. Let's say like this.
Indeed. So you mean that our skills will become obsolete, or let's say useless in the future?
Yeah.
We are already useless. No, that is true. So anyway, that's the tech industry.
Furniture.
Yeah.
No, good. So I guess
we are at the end of our episode today. So thank you so much, Richard, for being with us. We could continue forever, for hours and hours, but okay, let's say stick with our 20, or in this case 30 minutes.
Yeah.
Thank you also, Stephane, and see you next time.
Yeah, thank you guys.
Thanks, everyone.
Thank you, Massimo. Talk to you soon. See you.
Bye.